The transition altitude is the altitude at or below which the vertical position of an aircraft is expressed and controlled in terms of altitude. In the United Kingdom, its value is commonly 3,000 or 4,000 feet. The transition level is the lowest flight level available for use above the transition altitude. At and above transition level, vertical position is expressed as a flight level. The transition layer is the airspace between transition altitude and transition level. When climbing through it, the aircraft's vertical position is expressed in terms of flight level. When descending through it, in terms of altitude. Flight levels are surfaces of constant pressure related to the standard pressure datum of 1013.25 millibars. Flight levels are separated by specified pressure intervals. In the United Kingdom, these intervals are 500 feet between transition level and flight level 245, while from flight level 250 upwards they are 1,000 feet. A flight level is expressed as the number of hundreds of feet which would be indicated at the level concerned by an ISA-calibrated altimeter set to 1013.25 millibars, or 29.92 inches of mercury. For example, with 4,500 feet indicated, the flight level would be flight level 45. It should be remembered that the altimeter indicates height above the pressure level set on the subscale. The three settings normally used on the subscale are shown on these buttons. Select them to find the definitions of each. QFE is the aerodrome level pressure, which, when set on the subscale, will cause the altimeter of an aircraft on the ground to read 0, assuming there is no instrument error. In flight, with QFE set, the altimeter will indicate height above the aerodrome QFE reference datum, provided ISA conditions obtain between aerodrome level and the aircraft, and there are no other altimeter errors. In practice, QFE is used mainly for circuit flying and gives a good indication of height above the aerodrome. QNH is used mainly when flying below transition altitude. It's an equivalent mean sea level pressure, calculated by air traffic control from the aerodrome level pressure. With QNH set on the subscale, the altimeter of an aircraft on the aerodrome indicates aerodrome elevation, that is, the height above mean sea level. In flight, the altimeter will indicate altitude, but this will only be the true altitude, the height of an aircraft as measured from mean sea level, if the mean temperature in the column of air beneath the aircraft is the same as in ISA conditions. When 1013.25 millibars is set on the subscale, the altimeter shows the pressure altitude or pressure height. This setting is used in the United Kingdom above the transition altitude or transition level. Select any of these buttons to learn more about the main altimeter errors. With many types of altimeter, the response to change of height is not instantaneous. This causes the altimeter to underread in a climb and overread in a descent. The lag is most noticeable when the change in altitude is rapid and prolonged. Manufacturing imperfections, including friction in the linkage, cause errors throughout the operating range. The errors are kept as small as possible by adjustments within the instrument, and the calibration procedure ensures that they are within permitted tolerances. Residual errors may be listed on a correction card. Position error is largely due to the inability to sense the true static pressure outside the aircraft, as we mentioned earlier. The error is usually small. Maneuver-induced error is caused mainly by transient fluctuations of pressure at the static vent during change of pitch attitude. Even with no other errors at all, the pressure altimeter will not indicate the true altitude, the height above mean sea level, unless the surface temperature and lapse rate of the column of air are those which were assumed in the calibration of the altimeter. Where the temperature at your cruising level deviates from the international standard atmosphere, an approximate correction can be made with most navigational computers. The correction can only be approximate since temperatures in the rest of the column of air are not known. When flying in air which is colder than the international standard atmosphere, which will have an air density greater than international standard atmosphere at that altitude, the altimeter will overread. When flying in air which is warmer than the international standard atmosphere, which will have an air density lower than international standard atmosphere at that altitude, the altimeter will underread. If the static source becomes blocked, the altimeter will not register any change in height. The height at which the blockage occurred will still be indicated, regardless of any climb or descent. The following checks of the altimeter should be made before flight. The instrument dial glass must be clean and undamaged, and the correct altimeter setting must be set on the subscale. Air traffic will pass you the correct altimeter setting, and once you have it set, you can check that the altimeter reads within plus or minus 50 feet of the apron elevation. The apron elevation should be displayed in the Airfield Operations Center or, alternatively, it may be marked on the aeronautical chart you are using.